So welcome back to First Take Math with Brian Thomas. Again, Jason, thanks for doing a wonderful job tonight. Tonight, we want to continue on with talking about multiplying by 10. So if I look at this example, 7 tens, we know that 7 tens would mean 7D. So if I count out 7 $10 bills, we know that would play out as $70. So 7 tens is 7D. So when I write that on paper, that zero has a special name. A lot of times we'll call that zero a placeholder. Without that zero, it would just be 7 ones. With that zero, it becomes 7 tens. So a really important thing to pick up on is when I multiply 8 times 10, 8 times 10 means 8 tens, or that is 8E. Okay? A way to look at this is when you multiply by 10, multiplying by 10 increases the place value. So increasing place value just means all you got to do is add a zero to increase place value. So what we're trying to do is associate multiplying by 10 essentially means add a zero to a problem because that's increasing place value. So when I look at 7 times 10, notice that 7 you start with multiplying by 10. Essentially, all you do is writing a 7 and adding a zero. 12 times 10 is 120. Another way to look at it though is you got this 12. Multiplying by 10 means you have 12 tens, or you simply just stick a zero on in there to shift the place value over to 12 tens. 542 times 10, again, all I got to do is add a zero, and that's going to shift over my place value for me. Now, if I look at it, example number 4, multiplying by 100. Another way to look at this is I can say this is 6 times 10 times 10. Now, granted, I mean, most of y'all know 6 100ths is already 600. But another way to look at this is 100 is made up of multiplying by 10s. And multiplying by 10, what you should equate that is adding a zero. And if I multiply by another 10, I have to add a zero. That's our kind of our shortcut to all this. This is kind of what we call our mental math. So 6 times 10 would be then just simply 600. Because again, multiplying by 10 would mean to stick on 2 zeros. Now if I look at 4 times 20, again, this is not hard math because 4 20s we can do in our head. That would be just 20, 40, 60, and 80. But another way to look at this problem is I can look at this as 4 times 2 times 10. 20 is the same thing as 2 tenths. So when you see a zero, that means you're multiplying by 10. So I can change this problem to 4 times 2 times 10. Now, multiplication, you can multiply in any order you want. So I can just simply say, well, 4 times 2 is 8. And then I know that multiplying by 10 essentially means to add a zero. So really, the only math that's involved is multiplying 4 times 2. You know multiplying by 10 essentially is going to just add a zero to the problem. So that's going to give me my answer 8E. If I slide over to this problem, I have 60 times 30. Another way to look at this problem is to say, well, 60 is 6 times 10. Because when you see a zero, that should tell you that you're multiplying by 10. And then you're multiplying by 30, or again, that means 3 times 10. And again, when we see this problem, I can rearrange this problem as 6 times 3 times 10 times 10. I can change the order of a multiplication problem. And what this allows me to do is instead of focusing on 60 times 30, this allows me to focus on 6 times 3. Well, 6 times 3 is going to be 18. And each time we see multiplying by 10, that essentially means to add a zero. So this becomes 1800. So when I look at this last example, I have negative 50 times negative 300. If I look at this problem, a way to look at this is simply say I have a negative 5 times a negative 3. And then each zero is going to mean that you're multiplying by 10. So I'm going to multiply by 3 tenths. So that means multiply by 10, multiply by 10, and multiply by 10. So I can model this problem like this. And then the math becomes rather easy because all I got to do now is multiply -5 times the -3. Well, we know 5 times 3 is 15, and we learned that when you multiply, negatives are like a light switch. It's going to flip to negative, and then it's going to flip back to a positive. So I do get a positive 15 there. And when you multiply by 10, multiply by 10, multiply by 10, that essentially means stick on 3 zeros. And therefore, we get our answer of 15,000. So that's an easy way to mentally do this problem, because I really wouldn't even have to write that down. I can mentally see that -5 times -3 is 15, stick on 3 zeros. And you do that problem without a whole lot of effort. I'm out of breath. All right, well, thank you for tonight. Stay tuned for tomorrow.